Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I am going to solve chemistry paper of 12th standard Goa board which was asked recently in the exam which was held in March month. So yeah, let us start the paper of 2024-25. So this question paper, the timing given is 3 hours and maximum marks for this paper is 70. Okay, so it begins with the MCQs. So let us start with the first question. First question here is concentration of ore by Froth flotation method is mainly used for dash. Now in our metallurgy chapter we have learnt different methods uh, for concentrating ores. So one of that method is Froth flotation method, and in that we use specially the sulfide ores. Okay, so there are many methods such as hydraulic washing, magnetic separation, then Froth flotation. So in Froth flotation process we mainly use which ores? Then sulfide ores. So here the correct option will be sulfide ores. Next question is from biomolecules. So in that the question is in a polynucleotide the linkage which joins two nucleotide is dash. Now here they have asked the linkage which joins the nucleotide. Now in this chapter we have learnt three types of linkages: glycosidic, peptide and phosphodiester. These are the main linkages. Glycosidic is used basically in carbohydrates, and peptide is used in amino acids, proteins. Phosphodiester is used here, meaning phosphodiester is the linkage which links two nucleotides. So answer is phosphodiester linkage. Then next question, the coordination number of cobalt in this compound is dash. Now here basically we have this particular complex compound in which there are three ligands, En meaning ethane 1,2 diamine, having 3 plus charge on the whole compound. So here first we will try to know what is coordination number. Now coordination number means how many ligands are attached, or through how many bonds ligands are attached to the central metal atom. Here there are three En. En means ethane 1,2 diamine. Three ligands are there, same. And En, we should know that it is a didentate ligand. Now most of the ligands that we have come across, they are single, meaning unidentate, and unidentate means they can form only one bond to the through the central metal atom. So if this is a central metal atom, okay, CO, then normally the unidentate ligand will be attached this way, meaning only through single bond. But En, since it is a didentate, it will attach this way, meaning it is forming two bonds. Okay, two bonds to a central metal atom. So we will have this type of En structure. Okay, so En, and similarly we have three, total three, so two more. So this type of structure will be there. Now we can see, though there are three En, bonds are 6, meaning bonds are double. So coordination number will be also double, meaning 6. Okay, so this will apply only in the case of didentate ligand. For example, En and oxalate ion. So these two are the main examples of didentate ligand. So coordination number is 6. If there was unidentate ligand over here, then coordination number would have been 3. So this concept is applied in this case. Next is from surface chemistry, a plot of log x by m versus log p for adsorption of a gas on a solid gives a straight line with slope equal to dash. Now this question is related to Freundlich isotherm equation. In that we plot a graph, and in that slope is equal to what? So the answer is slope is equal to log k. Okay, you will come to know through the equation. Okay. Then fifth question, that is MCQ only, is chlorine containing artificial sweetener which is stable at cooking temperature and has appearance like a sugar is dash. So this is from chemistry in everyday life, and in that chapter we have seen many concepts or many questions are asked related to the artificial sweeteners, then detergents and all. So this is related to artificial sweetener, which is a uh, there are many artificial sweetener actually, saccharin, aspartame, maltitame, but here some particular information is given. So chlorine containing artificial sweetener which is stable at cooking temperature and has appearance like sugar is dash. So here the answer is sucralose, because sucralose is stable at cooking temperature and it has appearance like a sugar. Next question is, a compound formed by elements X and Y crystallizes in a cubic structure in which atoms X are at the corners of the cube and atoms Y are at the face centers. The formula of the compound is dash. Here we have learnt one way to derive the formula through this information. So we know that elements, which elements we have X and Y. Okay, we have X and Y element. So they crystallizes in cubic structure, and atom X, they are at the corners of the cube. Corners means what they will occupy. Corners means at each corner we have 1/8 atom. Okay, but how many corners do we have? We have total 8 corners. So 1/8 into 8 will be 1. Okay, and y atoms are at the face center. So how many faces do we have? 6 faces for cube, and each face will occupy half atom. So half into 6. Okay, so half into 6 is how much? 3. So it will become x1 and y3. So the formula will be xy3. Next question is from chemical kinetics. When the initial concentration of the reactant is doubled, half-life period of the zero order reaction is dash. Now there is one statement saying that initial concentration of the reactant is directly proportional to its half-life. Okay, so here zero order reaction, initial concentration is double, so half-life will be how much? So half-life will be also doubled since it is directly proportional. Next question is 8th question. The geometry of XeOF4 is dash. Okay. So geometry of this particular compound. Now this is from your P block elements, and in this chapter in group 18 they have given all the noble gases, information related to noble gases and compounds. So in the last page of this chapter you will find the structures of this. Okay, geometries and all will be given. So one of this compound is XeF4, which has the geometry square pyramidal. So this is having square pyramidal geometry. Next question is, differentiate between fibrous protein and globular protein with respect to its solubility. Now this is from biomolecules, and they have asked to differentiate between these two proteins, but only related to its solubility. So we cannot write any particular point over here, we have to write only related to solubility. So fibrous protein, now fibrous protein, they are insoluble in water, but globular proteins, they are soluble in water. So related to solubility we can write these 2 points, that fibrous are insoluble and globular are soluble in water. Now next is about the diagram. Draw a neat label diagram of tetrahedral void. Now this diagram is from solid state, in which you just have to show how the tetrahedral void is created. That we can show by showing the spheres this way, 3 spheres. Okay, now you all can refer to the textbook for that diagram properly. So here this void which is created, okay, this void which is created is called as a tetrahedral void. Then next is, what type of detergent is used in the toothpaste? So in toothpaste, which detergent is used? This is a 1 mark question from last chapter. So the answer here is sodium lauryl sulfate. So we have two types of detergents basically, anionic and cationic detergent. So here we use, in toothpaste we use sodium lauryl sulfate. The name of detergent is sodium lauryl sulfate. Next is draw a neat diagram for the preparation of metal salts by Bradick's arc method. Now this is frequently asked question which is asked in most of the papers. So Bradick's arc method. Now this is one of this this is one of the method which is used to prepare the colloids, preparation of colloids. So preparation of metallic salts is done by this method. For example, gold, silver. Okay, so Bradick's arc method, especially we use gold salt to prepare gold salt. So here in your surface chemistry chapter you will find the proper diagram. So I will draw the rough over here. So this is a ice bath which is taken, and then in that we have to put this container, and in that two metal rods are put. Okay. This way they are put. And here metal is put, and then the process begins. Okay, so you have to draw the diagram properly, and then you have to label the diagram in a proper manner. Next is complete the following reaction. Now this is from P block elements only. HNO3 nitric acid. So group 15 elements you will find this. Zinc, when treated with dilute nitric acid, we get which two compounds? So here first main compound that we get is zinc nitrate. So Zn NO3 2. So Zn NO3 2, and since 4 zinc are there, we have to write here 4 Zn NO3 2, and plus second one is N2O. N2O and 5H2O. So you have to see after balancing how many N2Os you have to take. But since there are 4 zinc, we can take 4 directly over here, and this number is already given, so you have to balance accordingly. Okay, next is what type of magnetism is observed when magnetic moments are oppositely aligned and cancel out each other. Now in solid state chapter at the end we have this concept of semiconductors, in that magnetisms are given. So which type of magnetism we can observe when magnetic moments are oppositely aligned? So there are 3 types basically which are given with the diagrams: ferromagnetism, antiferro and ferrimagnetism. So whenever they cancel out each other, it comes under antiferromagnetism. So in that magnetic moments cancel each other. And here example of antiferromagnetism is MnO, which is not asked here, but in exams they asked in direct question. In that direct they can ask show the magnetism shown by MnO. So in for that answer will be same, antiferromagnetism. Next question is, which stoichiometric defect does not change the density of the crystal? Now density of the crystal, we have 2 stoichiometric defects. Mainly they are Frankel defect and Schottky defect. So if we see Frankel defect, in Frankel defect one cation goes missing from its site and it will occupy the interstitial site. Okay, so that means it is leaving its original site and occupying the interstitial site in the same lattice. So density will remain same, density will not change. But in Schottky defect, if you remove one cation, if one cation is removed, one anion will also be removed. So they are not taking the place in the same lattice, but they are leaving the sides, both one cation and one anion. So here the density will decrease. The question is which does not change density. So here the answer will be Frenkel defect. Next question is from solutions. So the name the type of deviation and azeotrope shown by a mixture of ethanol and acetone. So in solution chapter we have two types of deviation, positive as well as negative deviation, which comes under the solutions which does not follow Raoult's law. So here this is an example which they have asked which type of deviation. So ethanol and acetone basically they show positive deviation, and azeotrope they show which is minimum boiling azeotrope. So these things we should know related to the positive and negative deviations. Next is define coagulation of a colloidal sock. So what is coagulation? Coagulation is the method of accumulation of colloidal particles to settle down as a precipitate, meaning how the coagulation takes place. So coagulation of colloidal particles to settle as a precipitate to form a PPT. It is called as a coagulation of a colloidal salt. Okay, and then two methods by which coagulation of lyophobic salts are carried out. So here the two methods, we have different methods. So from that, one method is electrophoresis. So by doing electrophoresis we can carry out the coagulation of lyophobic salts. And then one more method is persistent dialysis, meaning if you carry out continuous persistent dialysis, then also we can carry out the coagulation of lyophobic salts. Okay, then next question is from electrochemistry, state Kohlrausch's law of independent migration of ions. Now this is very simple and frequently asked question. Okay, so Kohlrausch's law, what it states? It states it is related to the limiting molar conductivity. So it states that limiting molar conductivity of an electrolyte is equal to or is equal to the sum of the limiting molar conductivity of the individual ions present in that. So if you consider NaCl, okay, NaCl is an electrolyte. If you take it and if you find out the limiting molar conductivity of NaCl, okay, lambda naught, then it will be equal to its individual ions limiting molar conductivity, that is lambda naught of Na plus and Cl minus. So Na plus and lambda naught of Cl minus. Okay, so this is the this example you can give to understand more better. So first of all, statement, that is the limiting molar conductivity of electrolyte is equal to the sum of the individual molar conductivities of its ions. Then next is draw the diagram of Leclanché cell used in transistors and clocks. Now this is primary batteries or primary cells which are used. Now it is also called as a dry cell. A diagram which is given in the textbook, meaning in the chapter electrochemistry, you have to draw the same diagram with neat labeling. Okay, then next is draw the names of monomers used for preparing nylon 6,6 polymer, and on the basis of molecular forces identify the class of polymer to which it belongs. So nylon 6,6, which monomers are used? Here we use the monomer like adipic acid. Okay, adipic acid is the one monomer, and hexamethylene diamine. So adipic acid plus hexamethylene diamine is used to prepare nylon 6,6 polymer. And on the basis of molecular forces, we can classify this polymer to which class? It is polyamides. So it comes under polyamides. Okay, so I will stop here. 18th question is the last. Next 18, 17 questions which are left we will solve in the next part, and we will finish the paper solving. So most of the organic part we will do in that part. Okay, thank you so much.